Hey everybody, so this is just a quick video on going over the free body interactive practice that you did yesterday. So let's go over some problems. So we were asked to draw a free body diagram for groceries on the table. Again, you were asked to watch the simulation and then draw those free body diagrams for those scenarios. So one of our scenarios was for groceries on a table. Okay, so let's just start by drawing the groceries on the table. That's all the food in the groceries. And this is our table. Okay, again, so you're going to have some forces acting on this, right? We actually have two, right? The weight here, and then the support force from the table. All right, so using our object on object notation, we would draw the center of mass here, and then we would draw the forces acting off of it. So we have the force of gravity on bag. Okay, the bag is the object in this case. And then we have the force of the table on bag. Okay? And just pretend that those are straight. I'm so sorry. I don't know why my pen is not allowing me to draw straight here. Okay, moving on to the next one. So draw a free body diagram for a horse pulling a sleigh on a separate sheet of paper. Okay, so let's just get into the holiday spirit here and draw a sleigh. So label this as sled or sleigh. Okay, I'm really bad at spelling, so I'm just going to go with sled. And this is the sled bottom so that it can slide across the snow. And then attached to that sled is our horse pulling the sled. I know it kind of looks like a unicorn, but it's fine. This is our horse. Okay, so now we need to separate it from the environment in their system. Okay, so what's the object that we actually want to focus on? Well, it is the sled or the sleigh. Okay, so let's just highlight the area that we really need to focus on. The object's motion that we actually want to look at. Okay, so that would be the sled's motion. So let's draw in the forces that are acting on this sled. So we have this force of tension here, and then we also have the weight of the sled, and then we have the support force from the ground, and then we have a force of friction. Okay, sweet. So let's use our object on object notation and draw an FBD. So we start with our dot, and we know that there is the force of the ground or on of the earth on the sled, right? Again, the sled is the object, and then we have the force of gravity on the sled. Sweet. And then we have the tension force from the sled. And then we have the frictional force. So the force of friction on the sled. All right, so that would be the FBD for our sled here. Woo! Nice. Let's move on to the next one. So let's draw an FBD for shoes held by laces. Again, if you don't remember from the diagram, there was like some shoes and they were being held by the laces only. Okay, so what are the forces acting on here? Well, let's just identify them before we draw the FBD, right? So we have the force of gravity, and then we have the tension force from these strings. Sweet, so let's draw the FBD. So again, we start with that dot, which represents our object, which is the shoes in this case, and then we have the force of tension on the shoes, right? And then we have the force of gravity on the shoes. Awesome. Let's go on to the next one. So now we have a puck sliding across the ice, and so this puck was already moving, and what did Galileo say? Well, he said that an object is going to continue in that motion until acted upon by non-zero net forces, right? So this puck is going across the ice, right? So what is slowing it down? Well, we have the force of friction here that is slowing it down. And then we have the gravity or the weight of the puck. And then we have the support force from the ice. Okay, and there's no force needed to keep it going because we're not asked to keep it going. We're just looking at it slowing down. Okay, so let's draw an FBD here. So this is the puck, or the center of mass of the puck. And then we have the force of ice on the puck. And then we have the force of gravity on the puck. And then we have the force of friction. And again, friction opposes that motion. So we're assuming that the puck was originally moving towards the left. Okay, let's move on. So draw a free body diagram for pushing a refrigerator. So let's draw by drawing a picture. So this is our fridge. This is the freezer, and this is, no, sorry, the top is the freezer and the bottom is like the fridge part. And then we have a person who is trying to push that fridge. Okay. Now let's identify the forces, right? So we have an applied force to that fridge. We also have the weight of that fridge, right? Then it's not crashing through the earth, right? So we have the support force, and then we have a little bit of friction. Okay, so let's draw the FBD. So we start with our dot, which represents that center of mass, and we draw the forces acting off of it. So we have the force of gravity on fridge, and then we have the force of ground on fridge, and then we have this applied force, so the force of person on fridge, and then the force of friction, or what that force is that opposing that motion. Okay. So that's what the FBD would look like. So this is getting into the further problem. So a book is at rest on the table. We have to draw a free body diagram for it. So let's go ahead and start with that table. We're drawing a book at rest on that table. And let's identify the forces. As we all know, there's only two, right? So it's that support force and the weight of the book. So let's draw an FBD for it using our object on object notation. We have the force of the table on book and the force of gravity on book. Woo! Next one. The girl is suspended motionless from a bar which hangs from the ceiling by two ropes. Draw a free body diagram of the forces acting on the girl below. Okay, so we have these ropes, and we have a bar, and then we have a girl hanging from those ropes. Sweet. Let's draw this free body diagram. Well, actually, let's identify the forces, right? So we have the weight of the girl, and then these tension forces supporting that weight. Okay, so using our object on object notation, we have the object, which is the girl, and then these two tension forces. Let's just draw them next to each other here. Theoretically, we're not supposed to do that, but for this case, let's just keep it as is. So the force of gravity on girl, and then the force of tension. Sweet. So the rightward force is applied to a book in order to move it across a desk with a rightward acceleration. Consider the frictional forces, ignore air resistance, and draw a free body diagram of the forces acting on the book below. So let's just say that we have a long table here, and you're trying to send that book across the table. Right, so your goal is to get it somewhere over there. And you need to apply a force to it in order to do so. So we know that there are two other forces acting on it, right? Support force and the weight. This is the applied force. And we are to consider frictional forces. So we know that the force of friction is going to go in that direction. Sweet. Now that we have identified all of our forces, let's draw in the FBD. So we have the force of the table on the book, the force of hand on the book, or you can just say applied force there, and then we have the force of gravity on book. And then, last but not least, the force of friction. And last one here. So the applied force of 50 newtons is used to accelerate an object that weighs 80 newtons to the right across the frictional surface. The object encounters 10 newtons of friction. Ignore air resistance. Draw a free body diagram for the forces. So this one's a little bit different, right? So this time we are actually given the magnitude for our forces. So we're not sure what the object is, so let's just pretend that it's a ball. A very heavy ball, but a ball nonetheless. Okay, so this ball is being pushed with an applied force of 50 newtons. And then we are given the weight of this ball, right? And we know that a weight is a force. And what is causing this ball not to crash through this table? Well, there is also an equal and opposite force acting. So we have that support force from the table. Okay, and then this ball is also being acted upon by a frictional force, which is 10 newtons. So now let's actually draw a free body diagram for this. All right, so we have this object, which is a ball in this case. We have the force of the table on the ball, or on the object, which was 80 newtons. We have the force of the gravity on ball, which is also 80 newtons, right? It's giving it weight. And then we have an applied force of how much? 50 newtons. And then we have a frictional force